in order for something to be independent, one of these three rules has to work. Now, we should remember when you see this part right here, this little line, that means the probability of A given that B already happened. If it's independent though, what does B have to do with A? Nothing. So that means if I'm looking at the probability of A given that B happened, B doesn't mean anything, so my answer is going to be whatever A is. If I'm looking at the probability of B given that A happened and it's independent, A doesn't matter, so my answer would have to match whatever B is.
But A and B, that'd be both.
If it says A and B, then I've got to do A probability of A times the probability of B and check and see if that works. All right? So like for this one right here, what I'm going to check is probability of G and H. Is that equal to the probability of G times the probability of H? So all I've got to do is plug the numbers in. Probability of G and H is 0.3. Probability of G is 0.6 and H is 0.5. All you got to do is multiply those out. If you get the same number, it's independent. If not, it's dependent. That's all you got to do. All right, are there any problems with that right there? If it gives you the A and B, G and H, whatever, check and see if it equals those two things multiplied together. All right, for this one, you've got a whole bunch of stuff up there, and we need to be able to pick out the stuff that we need. Base what you pick out off of the question. It says, are the events of being female and having long hair independent? Well, it tells me the F is going to stand for female and the L is the long hair. So what I'm going to check is female and long hair. Is that equal to what? What would I check it? Based off of that right there that we just did.
They can multiply together.
Does the probability of being female times probability of long hair equal that right there? Does everybody see where this came from? It asked me to do female and long hair. So that's what I'm checking. Does the female and long hair answer equal the probability of being a female times the probability of long hair? So go up to the words now and say, okay, female and long hair.
This will be 45%.
So 45%, we're going to change to the 0.45. Probability of being a female, what is that?
60.
So 0.60 or just 0.6 times the probability of long hair.
0.75.
Ooh.
%50.
50%. What is that 75 in there?
6.
No, what is the 75 in the question?
Of the female students, 75%.
But how do we use it?
Of the female students.
But what are we going to use it for?
Put it into the female students.
Look at our equation. Where are we using the 0.75?
You don't use it.
You don't. It's extra information. All right. So somebody tell me on the calculator, what is the 0.6 times 0.5?
0.30.
0.30. So I get 0.45 equals 0.30. What does that mean? That's dependent, not independent. All right, if it asks independent or dependent, we've got to use these rules back here. If it gives you the little slash thing, probability of A given that B happened, it's got to match A. Probability of B given that A happened, it's got to match B. If it gives you the A and B, you got to multiply them together to see if it works. All right, so here, for this first one, if it gives me the A and B, I've got to check that A times B. So the A and B is 2 over 25. Does that equal A times B? Probability of A is 2 over 5 times the probability of B is 1 over 5. So all you got to do is type this in and see if it works. So I would do 2 over 25 equals 2 over 25. They match. That tells me it's independent. All right, so for number 2, I'm going to check A and B, which is 1 over 25. Does that equal the A part, which is 2 over 5, times the B part, 1 over 4? So does 1 over 25 equal 1/10 when you multiply it out? Are those two things equal? If they're not equal, that means it is not independent, which means it has to be dependent. If it ever gives you these, those are the easiest ones. Because what I'm checking here is if it talks about the probability of A given that B happened, if it's independent, what's going to happen? What's the answer going to be?
It's gonna be the same.
Same as what?
As both of those multiplied.
Go back to here.
Because see, you take the A, if it's like that line, then the B's gonna be canceled out. It's gonna be the same as
It's
A.
going to match the A. If the B comes first, it's got to match the B. So when I'm looking here, A comes first. So does this part right here match
No.
A?
That's
If it doesn't, that's dependent. Because what I'm checking is, does this A match that A? If it doesn't, it's dependent. If the B comes first, I'm going to check, does the B part equal the B part by itself? All right, look at the last one down here. People always mess this one up. It gives me the A and B stuff. So I'm going to check A and B equals the probability of A times the probability of B. Do those things match? Well, the probability of A and B is 3 over 40. Are we good with that? All right. Probability of A. What's the probability of A? How much? No.
Oh, not A.
Not A is 3/4. So then what is the probability of A then? If not A is 3/4,
1/4.
A is 1/4. Where does that come from? Remember how we did the not A stuff?
It
Or the
says it's
stuff?
not A, so
We subtracted the
subtract that.
the two?
so it's one left.
subtract the 2. 4 minus 3 is 1. Times B, well B is 3/10, so I can put that one down. But if you ever see this, the not A part, you're going to have to change it to the A or the B or whatever you need. All right, so we can't use the not A in this equation over here. So I get 3 over 40 equals 3 over 40. So that's independent. All right, first thing, figure out what your total is.
19.
24.
All right, so there's 24 total, and it says that they're replaced. So what does that tell me for the bottom number? Stays the same every time. So I know it's going to be 24 each time. All I got to do then is pick out what it says. Well, red is 6, purple is 2.
You're going at 1 over 48.
All right, same deal. I know the 24 is going to be the bottom each time. Green is 8, red is 6, 1/12. Is that right?
Yeah.
All right, yellow and not blue. So yellow would be 3 out of 24.
And not blue would be 19 out of 24.
Not blue is 19 out of 24. Answer is 19 over 192. Not green and purple. Well, not green would be 16 out of 24. Purple would be 2. Answer 1 over 18. Yellow and then yellow. Again, I know it's going to be 24 each time on the bottom.
33.
There's 3 and 3. Why does it stay 3 and 3? Because you don't leave it out. You're replacing it. You take the one out, you put it back in, you still got 3 yellows in the bag. So 1 over 64. Green, blue, and yellow. I know each one is going to be a denominator of 24. Green is 8. Blue is 5. And what is it? Yellow is 3. What do I wind up with?
5 over 576.
5 over what?
576.
All right. I know if it says that it is not replaced, that means the bottom number has to change each time. So for this, I know it's going to start with 52 and then go down to 51. Well, how many reds do I have? And then I have 26 black cards still left. So my answer winds up being what?
13 over 51.
13 over 51. 3 and 9. Well, there's 4 3s and then 4 9s. Make sure the bottom number goes down by 1 each time. Wind up with
4, 662.
all right, a red ace and a 5.
4, 52.
2 over 52
Yeah, because
is red.
yeah.
And then 4 over 51 for the 5. What's my answer?
8.
How much? 2 over 663. All right, 4 and 4. You got to be careful on these. I've got 4 of the 4s to start with.
And then you got 3.
But then since it's repeating,
3.
I've already taken one of those 4s out. I only got 3 the second time. This is 1 over. What's my answer?
221.
221.
4.
Right. Diamond and a club. Well, I've got 13 diamonds and then 13 clubs, but it's over 51 because I'm dropping that one card.
So it's 13 over 204.
204. All right. Less than 4. How many less than 4s are there?
12.
So 12 out of 52 times 4 out of 51 for the kings.
4 over 221.
Queen, king, and ace, and this is the one that's not doing right on the calculator. Should be 4 over 52 times 4 over 51 times 4 over 50. If you do the fraction, it was 64 over 132,600, which could be simplified. It was some long decimal, something on there that the calculator gave. Right now, we'll just go with that.
Coach, isn't that less than 4, wouldn't that be 16 on the one above it right there? Less than 4? Because it's ace, 1, 2, 3.
It's ace 2, 3.
That's right.
And then,
Yeah,
so that's
that's
3,
true,
6,
yeah.
9, 12. All right, not a 5 and a 10. Well, not a 5. How many not a 5s are there?
Count that twice.
48.
And then 10. Now, this one, I was thinking about this one a second ago. It kind of really depends on what you pick out that first time, but there's no way of knowing. If I picked out a 10 the first time,
Yeah,
then there's only 3 left.
you don't know that.
But, so this really probably is not a great problem that I came up with, so. What's my answer here? What's my answer?
16. Over 220.
16 over 221.
Mm-hmm.
And then the last one, a black 6, well, there's 2 of those, and a red face card. How many of those? 6, ain't it?
6.
Out of 51. So I wind up with,
1 over 221.
is that right? 1 over 221?